Imagine standing in the heart of London, surrounded by skyscrapers of glass and steel. Now imagine that just meters beneath your feet lies another city entirely. Not just ruins, but a complete world. The Roman city of Londinium. For centuries, this ancient metropolis remained a mystery. Its stories buried under layers of medieval plague pits, Saxon settlements, and Victorian sewers. But today, a new breed of archaeologist, a digital detective, is on the case. And their tools aren't just trowels and brushes, but lasers, code, and powerful algorithms. Welcome to G Fun Facts Online, where today we're going beneath the pavement to see how technology is resurrecting Roman London. London is a palimpsest, a manuscript where new text has been written over old. Every time a new foundation is dug, it offers a fleeting glimpse into that older text. The challenge has always been immense. How do you excavate a 2,000-year-old city without bringing a 21st century global hub to a grinding halt? You can't just close a major financial district for a year. Project delays cost millions of pounds a day, and the ancient remains themselves are incredibly fragile. Once exposed to air after millennia in the damp earth, materials like wood and leather can decay in hours. The old way of slow, destructive digging was simply not sustainable. This is where the revolution begins. At the forefront of this new era is the Museum of London Archaeology, or MoLA. They are the pioneers turning archaeological sites into massive datasets. So, what's in their high-tech toolkit? It all starts before a single spade touches the ground, with something called geophysical surveys. Think of it as a medical checkup for the Earth. Archaeologists use a combination of techniques, like a doctor using an MRI, a CT scan, and an X-ray for a complete diagnosis. First, they might use magnetometry. This technique detects tiny magnetic variations in the soil. Fired materials, like a brick wall, a pottery kiln, or a blacksmith's hearth, have their magnetic particles aligned by the heat, making them stand out like a beacon to the magnetometer's sensors. Then there's earth resistance. This involves passing a small, harmless electrical current through the soil. A buried stone wall will resist the current more than damp soil in an ancient ditch, creating a high-resistance anomaly. And of course, there's ground-penetrating radar, or GPR, which sends radio waves into the ground. These waves bounce off buried objects, creating a 3D map of what's below. By combining these different data sets, archaeologists can create a ghostly but remarkably accurate blueprint of buried structures before they even think about digging. This allows them to plan their excavation with surgical precision, targeting the most important areas and avoiding costly, time-consuming searches. Once they do break ground, the race against the clock begins. This is where 3D documentation has become a game-changer. Two key technologies are 3D laser scanning and photogrammetry. A 3D laser scanner sits on a tripod and rotates, shooting out millions of laser points to measure the exact position of every surface in the excavation trench. This creates a point cloud, a digital cloud of millions of coordinates that form a perfect, metrically accurate 3D model of the site. The precision is mind-boggling, capable of capturing the tool marks on a Roman stone or the subtle curve of a collapsed roof. Photogrammetry achieves a similar goal, but with photography. An archaeologist can simply walk around an artifact or a section of wall, taking hundreds of high-resolution photos from every conceivable angle. Sophisticated software then analyzes these images, identifying common points and stitching them together to create a photorealistic, fully textured 3D model. The result of both techniques is a digital twin of the excavation. This isn't just a picture, it's a verifiable, measurable replica. A researcher in Tokyo can digitally measure the diameter of a post hole, and an engineer in New York can analyze the structural integrity of a Roman wall, all without leaving their labs. A task that once took days of painstaking hand drawing can now be done in a matter of hours, capturing a moment in time before the site is gone forever. All of this incredible data, the geophysical maps, the 3D models, the exact coordinates of every single pottery shard, flows into one master program, a Geographic Information System, or GIS. This is the ultimate tool. Imagine the most powerful version of Google Maps you can conceive. Mola's GIS is a multi-layered digital map of London through time. Archaeologists can use a slider to literally peel back the centuries. At one end, you have the modern city. Slide it back, and the Victorian buildings appear. Further back, you see the tangled streets of the medieval city. And finally, the Roman street grid, the Forum, and the amphitheater resolve into view. They can use it to ask complex questions, like, show me all locations where first-century coins were found near the buried Walbrook River, helping them map early commercial activity. It's a time machine map that reveals the patterns of life and death over 2 millennia. So how does this work in the real world? Let's look at 2 recent skyscraper sites that have transformed our understanding of Londinium. First, the construction of Bloomberg's European headquarters. Here, archaeologists uncovered the stunning remains of a 3rd century temple to the god Mithras. Mithras was a mysterious deity, likely of Persian origin, whose cult was popular with Roman soldiers and merchants. It was a secretive religion, with rituals conducted in dark, cave-like temples. Instead of just recording the find, Bloomberg and Mola embarked on a revolutionary project. They painstakingly reconstructed the temple as an immersive public experience, located 7 meters below modern street level, close to its original spot. Using the 3D scans and digital models, they rebuilt the temple, combining original stones with new materials precisely matched to Roman mortar samples. Today, you can visit the London Mithraeum for free. It's a multi-sensory journey. A custom soundscape fills the air with whispers and chants. A light haze evokes the smell of incense, and a dramatic light show slowly reveals the temple walls and the altar, mimicking the secret rituals of the Mithraic cult. But the temple wasn't the only treasure. Preserved in the oxygen-free, waterlogged mud of the buried Walbrook River, they found over 400 Roman writing tablets. These were the disposable notepads of their day, thin wooden sheets coated in blackened beeswax, where people would scratch messages with a stylus. These tablets contained the daily chatter of the first generation of Londoners, loan agreements, business deals, even a party invitation. Crucially, they contained the very first written reference to the city, Londinium. Reading the faint scratches was a monumental challenge, solved by a technique called reflectance transformation imaging, or RTI. A camera captures dozens of images of a tablet, each lit from a different angle. A computer then compiles this data, creating a digital model where you can control a virtual light source. As you drag the light across the screen, the faint indentations of the stylus suddenly pop into sharp relief, making the 2,000-year-old handwriting perfectly legible. We can read a contract from January 8th, AD 57, where one man acknowledges a debt to another. It's the voice of Roman London, speaking to us directly from the mud. More recently, in preparation for a new skyscraper at 85 Gracechurch Street, another astonishing discovery was made. In test pits dug in the basement of an existing office building, Mola archaeologists hit massive foundations, some over 1 meter thick and 4 meters deep. They had found the beating heart of Roman London, the city's first great basilica. In Roman times, a basilica wasn't a church, but the central public building of a city. It was the law court, the administrative headquarters, and the stock exchange, all under one colossal roof. The sheer scale of the foundations suggests a building of immense civic importance, confirming Londinium's status as the capital of Roman Britain. And following the new model of archaeological preservation, the developers are incorporating the discovery into their design. The plans include a glass floor in the new skyscraper's lobby, allowing the public to look down onto the ancient walls, with an immersive exhibition to tell the story of the building that once stood as the nerve center of the entire province. The people driving this are a new breed of explorer, combining deep historical knowledge with proficiency in drone piloting, database management, and 3D modeling software. The ultimate goal of all this work is not just to record the past, but to bring it to life for everyone. Augmented reality apps like Street Museum Londinium already allow you to point your smartphone at a modern London street and see a ghostly overlay of the Roman buildings that once stood there. The next frontier is fully immersive virtual reality. Imagine putting on a headset and not just seeing, but experiencing Londinium. You could walk through the bustling forum, hear the merchants hawking their wares, and then step inside the magnificent basilica to witness a trial in progress. It's about moving from static museum displays to dynamic, lived experiences of history. This fusion of archaeology and technology has already transformed our understanding of Roman London. The story of the ancient city is no longer just being dug from the earth, it's being rendered from data. These digital detectives are not just preserving the past, they are ensuring that Londinium, a city once lost to time, has a future, ensuring its story can be told, explored, and experienced for generations to come.